So now that we talked about the mechanisms for configuring the common fork join pool, let's show an example that demonstrates how to actually do this in practice. And this particular example will show off a number of different things. It's going to show off how you can configure the number of threads in the common fork join pool by using manage blocker. And it'll also, hopefully, show us the consequences or the impact of doing this type of an operation. And what we're going to do is we're going to have 3 different ways of downloading a bunch of images and doing image processing on them. And we're going to test them with the same sets of data and then see which of these different approaches run fastest. And what we will probably see, hopefully, is that the approach that uses the default downloading behavior, where the number of threads does not increase as blocking occurs, will not perform as well as the versions that actually increase the number of threads. So we'll see if we get that result. This is a result from something I did earlier, and it worked the way I expected. But you never know when you do benchmarking, because your mileage may vary. You can get this example we're going to look at in the EX20 project in the live lessons folder in my, the Java 8 folder in my live lessons GitHub repository. So let's go ahead and take a look at this. So remember, we can control the size of the common fork join pool programmatically. We just talked about how to do that. And we're going to use the manage blocker interface here to adaptively add new worker threads to the Java common fork join pool. And we're going to see there's a bunch of different interesting ways to do this. So we're going to do it in this particular approach. This is one approach using manage blocker directly. We have some other approaches as well. So here's the basic behavior. This is called test download behavior. And you can see it takes in a function that will do the downloading using different approaches, a default approach, and then 2 different ways of using managed blockers. And that will then be used in conjunction with a parallel stream. And then we're going to benchmark this and see how long it takes to run. And ideally, what we'll find when we run this in a second is that the approaches that adaptively increase the number of threads will run better. And you can find this example here, and we're going to walk through it right now. So here we are in the EX20 project in my GitHub repository. And let's go ahead and take a look at this file. This is the main driver program that shows how to use Java parallel streams both with and without the managed blocker mechanism and the common fork join pool to download and store multiple images from a remote server. So it starts out by parsing any command line arguments, and then we make a new instance and run it. So here's the run method. The first thing we do is we warm up the common fork join pool so the results that we get back will be consistent. And then we run 3 different versions. We'll take a look at the run test method, which is going to be doing the timing. And you can see we're going to pass in method references to a method called download and store image. That's the default behavior, doesn't increase the size of the common fork join pool. We have another method called download and store image MB for managed blocker, which explicitly uses the managed blocker interface. And then the third and final test we run passes in a method reference to another method called download and store BT, which stands for blocking task. And you may remember your blocking task from the assignments you've been doing, where that has a nice little wrapper around the managed blocker mechanism that's a little cleaner. And after we're done, we print off the timing results and see what the results are. So now that we've talked about the different methods, let's go ahead and run the program. And you can see it's up and running. And I'll let it run. It's going to take a little while to run. In the meantime, let's go ahead and take a look at the run test method. You can see what run test does is it takes a function and a name, and it deletes all the files from the previous run. Garbage collects everything, so we can start out with a pristine state of all the memory available. And then it uses our good old run timer time run timing utility to call the method here called test download behavior. We'll look at that in a second. Passing in the function that was the parameter here and the test name. And that will then go ahead and run the test and record the amount of time it takes to run using the test name as the key to the map that stores the results. Let's go ahead and take a look at test download behavior. So test download behavior is another method that's parameterized by the download and store image function. So this is a good example of behavior parameterization. And you can see what it does is it goes and it grabs a list of URLs. Let's just take a look at what the URL list is. The URL list is going to take the list of image names, and these are all images that exist on my website here at Vanderbilt, and it converts those list of names to URLs using this clever little regular expression mechanism, and we end up then with a stream of names, and then we go ahead and collect those into a list. And I should probably just say to list here to bring things up to the normal modern way of doing things. So that's where we get the list of URLs. We then turn that list into a stream, a parallel stream, and then we call the map method to transform each URL by downloading and storing it. And then we create a list of images when we're done, which will be the images that have been downloaded and stored. And then we print out the name of the test and the number of images that were downloaded and stored. Given that, let's now go take a look at the different methods that are going to do the downloading and storing. So here's the very first one. This is called download and store image. As you can see here, this method does not use the manage blocker mechanism. It's simply going to download the image, we'll look at that real quick, and then it's going to store it. So download the image is a little helper method here that calls another helper method called download contents, passing in the URL. And what that does is it goes and it opens up the URL, opens a stream to the URL, and then it basically reads from the URL, rather from the stream, until we've read all the data in, and it writes it to the output buffer, which is an O stream. So we read everything in from the socket, and then we write it to the output stream. So that'll download the image, and then we make a new image from that, and then we store that image. And if we go look at store, you can see store just makes a temporary file, and then it writes the contents of the image to that file. So that's basically how we get things stored. Now, the thing to note about this particular example is it doesn't modify the number of threads in the common fork join pool. So let's take a look at another way to do this. This is a way, this download and store image MB is actually going to use the manage blocker mechanism to add an additional thread while this thread may block. Now we're going to do a little clever trick. It's probably too clever for its own good, but I like it for this type of a use. We're going to create a one-element array called image, and we're doing this so that in the anonymous inner class that we have defined here, we can update the image. We can't set something in an anonymous inner class that's a variable, so we have to make an array of one element and then set to that. An alternative way of doing this would be to use the atomic integer class or an atomic reference class and so on. This way works fine for what we're doing here. So what we're going to do is we're going to say make a new manage blocker anonymous object, that's what's going on here, and pass that to the manage block mechanism. Remember, manage block in the fork join pool in this context is going to compensate by adding an additional thread because this thread is about to block. So remember, manage blocker has two methods, one called block and one called isReleasable. We don't care about isReleasable, so we just have it return false. The block method is what we care about. What block is going to do is it's going to download the image at the URL, just like we looked at before. It's going to store it into image sub 0, and it'll return true when it's done. So that's how we're going to have the common fork join pool increase the number of images by 1. And then you can see here what this does is it goes ahead and stores the contents of the image array at location 0, which is the image that we just downloaded. So this approach works, and hopefully we'll see when we look at the performance results, it's a little faster than the default approach. The downside is, I think you'll agree, this is rather cumbersome and awkward to have to read and write. It's just kind of ugly. There's a lot of ceremony going over here, including this sort of wacky hack using a one-element array. So an alternative way to do this, which is much more consistent with how your programming assignment works, is to use the blocking task wrapper. So we have download and store image BT, which says blocking task.manage block, just like we'd always done. We pass in a supplier lambda expression here that says download this image. And by doing this, the blocking task manage block wraps all the gobbledygook dealing with manage blocker, so we don't have to know and care how that works, but instead it'll do it for us, but it'll still have the same effect as that more complicated code we looked at, and then we store the image on the local device. So those are the 3 different ways to do it. You'll notice a bunch of interesting things in this particular example. For example, the use of functions to do behavioral parameterization so we can have some really clean code here, something similar for run test so we can time this. And then the driver program calls the run test method, passing in the different method references, thereby allowing us to do behavioral parameterization. So now that we've talked about the implementation, let's go look and see what the results were. And the results worked the way I had expected them to work, which is good. So you can see that we called default download behavior, which downloaded and stored 42 images using only 10 threads, because that's the one that didn't increase the size of the common fork join pool. Whereas the other two methods, the one that uses the managed blocker and the one that uses the blocking task, downloaded and stored 40 images using lots more threads, because a new thread was created for every one of these things that would block. And then when we look at the results, you can see that the blocking task was the fastest, followed by the managed blocker, which was about the same speed, but test default download behavior was the slowest of the approaches. Not wildly different, but better to do it this way. And we would probably see even better behavior if we had more threads and more blocking operations and so on and so forth. So this is demonstrating how using the managed blocker mechanisms for the common fork join pool, or any fork join pool for that matter, can help to make your code more scalable.